Now that we know what programming is, the next question to answer is how do we program? Well, the first step to that is understanding programming languages. Going back to the peanut butter and jelly sandwich example from the last video, the amount of detail or style that you write instructions in, say like APA or MLA for academic papers, will be determined by the programming language you choose. There are various levels to programming languages, so to start, let's look at two of the more overarching ones, low and high level languages. Low-level languages like machine code and assembly languages rely heavily or even solely upon the processor you're programming on to determine what instructions you can use to program it. At the base level, all programs and scripts that programmers write need to be translated into these instructions that the processor can carry out in order to actually run what the programmer wants. Therefore, to do this, processors come with a basic set of instructions. These instructions specifically are a bit beyond the script of this video, but to break it down in our peanut butter and jelly sandwich analogy, these instructions are equivalent to your own everyday movements. When you move your arm or hand, at the base, your physical muscles or tendons are expanding and contracting to make these movements. These different muscle and tendon movements can be thought of as our instruction set. However, the problem comes in that each processor's instruction set can be different. So instead of only coming up with instructions for a human's muscle and tendons, we would also need to create different instructions for a monkey's body or even an alien. To put this all into a TLDR, low-level languages are equivalent to instructing each muscle and tendon in your body in order for it to carry out the process of making a peanut butter jelly sandwich. Now let's move on to high-level languages. High-level languages are designed so that you don't have to deal with the problems of different instruction sets. They may also provide some other benefits like making code less gritty to deal with, or making processes occur naturally within the language. In our analogy, high-level languages allow us to write instructions that all humans, monkeys, aliens, dogs, or anything else are able to use and follow to make a peanut butter jelly sandwich, even with their differences in body structure. High-level languages are more common to see in the real-world programming environments, but low-level languages are still out there and very much needed. Given that many new programmers are introduced to high-level languages, I will put my focus on these in my videos over low-level languages. High-level languages, however, still vary greatly in their complexity, ease of use, and just overall function. So with all the programming languages out there, how do you choose what language to learn to program in? Well, the answer is it all depends, mostly upon what you want to do. Do you want to make a website or an app? Well, languages like HTML, CSS, JavaScript, and PHP, as well as lots of others, are great for this case. Although a case can be made that HTML and CSS aren't really programming languages, but that's a whole other topic. Want to make a mobile app? Well, Java and Kotlin are two major languages for Android, and iOS uses Swift and Objective-C, although Swift has all but replaced Objective-C. Similarly, games, desktop apps, and microcontrollers like Arduinos all have hosts of languages you can use. This really all comes down to yourself and the research you do about the projects that you're looking into, as well as knowing what resources you have access to, whether it be books or other programmers, to know which language best fits your use case. Your best bet is to ask other programmers what they would recommend for your project, as well as see what other projects that are very similar to yours use for their language. There is no one magical language. They all have their own benefits as well as pitfalls. Also, don't let the memes that you may see floating on the internet persuade you or dissuade you from any language, as they could often be just not true, or only highlight the language's shortcomings, which again could just be blown out of proportion. Now that we know what programming languages are, how do we use them? Well, that's where IDEs, or Integrated Development Environments, come in handy. IDEs, however, are not the only ways to program, as you can program in almost any text editor you want. Yes, even stock Windows Notepad if you're into that kind of torture, but if you don't use an IDE, you'd be in charge of compiling and running all your code you write manually, which can be kind of a pain. Plus, you lose out on a lot of helpful features IDEs provide. So, what are IDEs? Well, they are programs that make coding and running programs easier and more intuitive for their users. They provide quick and easy ways of compiling and running code, usually just by the press of a button, as well as providing helpful highlighting features for marking mistakes in your program. For example, think of Microsoft Word. Sure, you could write that thesis of yours in Notepad, but Word allows for your writing to look nice, as well as provides underlines for misspellings of words and grammar. Because of how languages work, there really is no all-in-one IDE that can handle every programming language. Programs like VS Code, Atom, and Sublime do exist that support many languages, but these are really just text editors that can highlight errors for you. They usually lack the depth elements like running and debugging code, as well as tool integration, and they just aren't tailored for specific languages. These are great, however, for languages that you don't spend a lot of time working with, as well as for making small changes to files that wouldn't warrant the need of an IDE. Basically, normal text editor stuff. In all, for IDEs, it comes down to the language you're using and your own personal preferences. Again, do the research and ask around to see what others recommend, as well as why. And that's about it though. We are finally ready to start programming. So buckle up and prepare yourself, because in the next video, we will start to go over the basics of how to program.